In this video, we will show that the kinetic energy of a moving object is given by this formula: K equals a half times m times v squared, where m is the mass of the moving object and v is the velocity. We start first. The first step is we start from the power P equals the rate of change of the work over time, dw dt. So dw equals P times dt. The work dw is F dx. So at the left hand side we have F dx equals P dt. So P equals F times dx over dt. So P equals F times v, where F is the force and v is the velocity. But we know that P is d epsilon dt. The rate of P is in watts. Watts is joules per second. So we have the rate of change of epsilon with respect to time equals m times a, from Newton's second law of motion, F times a times v. The epsilon equals m times a times v dt. So we can work this out. M times v times a, the acceleration is the first derivative of speed with respect to time, so we can write this as v prime dt. We integrate from 0 to k at the left hand side, and here we integrate from 0 to t of v prime dt. So this can be written as the integral from 0 to k d epsilon equals m, the integral from 0 to t d dt v squared dt. The left hand side is just k, and also we have here a half in front of m. K equals a half times m times v squared, where we taken that v0 is equal to 0. The initial condition of the velocity is equal to 0. So our desired formula is obtained if we know the mass of the moving object and the velocity. We can compute the kinetic energy K in joules.